For years, Nvidia has owned artificial intelligence. Their chips are the engines in everything from ChatGPT to self-driving cars, and their lead seemed absolute. But what if that empire just got a serious reality check overnight? China just dropped something wild into the AI race. It's not another quantum computer locked away in a lab, but a photonic AI chip that they claim is already working inside real data centers. The headline number sounds almost fake. For specific AI jobs, it's 1,000 times faster than a top-tier Nvidia GPU. And according to the developers, this isn't future tech. It's being deployed right now in high-stakes fields like aerospace, biomedicine, and finance. This threatens to shift the entire balance of power in the tech world. This one development could be a crack in the foundation of Silicon Valley's dominance. So, stick around, because we're breaking down how a beam of light could change everything. To get why this is a big deal, we need to talk about a problem. A very big, hot, and expensive one. For over 50 years, the tech world lived by Moore's law, cramming more transistors onto silicon every 2 years. This law gave us the digital age, but Moore's law is out of gas. We're hitting the physical limits of silicon, facing weird quantum effects and staring down a crisis of heat and energy. Data centers are now choking on heat and power consumption. Training a single large AI model can burn as much electricity as a small city, and these computational temples need epic cooling systems just to keep from melting. We're trying to shove an ever-growing river of data through the copper garden hose of silicon. The electrons carrying information create friction and a ton of heat. This isn't just inefficient, it's a hard wall. The cost of power and cooling is now a bigger bottleneck than the hardware itself for many companies. For AI to take its next big leap, we don't just need a better chip. We need a new kind of chip. And that's what was just unveiled in Shanghai. A joint team from Shanghai Jiao Tong University's ChipX Institute, short for Chip Hub for Integrated Photonics Explore, and a startup called Turing Quantum just won a major award for a chip that tries to blow up the old way entirely. It was one of just 17 technologies recognized with the Leading Technology Award at the 2025 World Internet Conference Wuhan Summit, beating over 400 entries from 34 countries. They've created a programmable, large-scale photonic quantum AI chip. The mind-blowing claim is that for specific complex AI tasks, this chip is up to 1,000 times faster than a top-of-the-line Nvidia GPU. Let that sink in. Not 10% faster, 1,000 times. Skepticism is smart. We've heard Nvidia killers hyped up before. But this seems different because the developers say it's already being used in sensitive fields like aerospace, providing computing power support exceeding the limit of classical computers. The hardware itself is a 6-inch thin-film lithium niobate wafer that fits more than 1,000 optical components on a single slice. This level of monolithic integration is considered world-class. The magic here is a fundamental shift in physics. For 70 years, we've computed with electrons. This new chip computes with photons, particles of light. Think of an electronic chip as a crowded hallway. Electrons shove their way through, creating chaos and heat. That's electrical resistance, the core bottleneck of modern electronics. A photonic chip is like an empty hallway. You shine a beam of light and the photons travel at light speed with almost no resistance and generating next to no heat. This is the core advantage, replacing the slow, hot flow of electrons with the clean, cool, instantaneous movement of light. This Chinese chip uses a sophisticated material called thin-film lithium niobate, TFLN, to shrink and integrate all the parts. A key innovation is a new co-packaging technology that places both electronic and photonic components right next to each other on the same wafer. That proximity slashes latency and noise, boosting bandwidth. Shorter distance means lower error rates, which means higher throughput. Plus, light has another cool trick: parallelism. Using a technique called wavelength multiplexing, you can send multiple beams of light, each a different color, through the same pathway at the same time. Each color carries its own data. It's like turning a single-lane road into a superhighway, a perfect fit for the math that powers AI. The result is a chip that is not just fast, but also incredibly energy efficient, directly attacking the insane electricity and cooling bills of the AI industry. The developers call it a photonic quantum chip, which brings to mind giant cryogenically cooled quantum computers. So, is that what this is? The short answer is no, but what it is might be more disruptive right now. This is not a universal quantum computer. It can't run the algorithms that would break encryption. Instead, think of it as a quantum-inspired accelerator that uses quantum classical hybrid logic. It uses photons, which are quantum particles, to perform a massive number of calculations at once for specific, real-world AI tasks. This photonic chip is more like a commercial jet engine than an F1 race car. It uses advanced physics, but is engineered for industrial-scale use right now. In fact, the team claims that thanks to this photonic design, systems that used to take 6 months to assemble and deploy can now be ready in just 2 weeks. The developers also claim the architecture is scalable and could one day support up to 1 million qubits. While these aren't the same as qubits in a universal quantum computer for tasks like complex simulations and pattern matching, this massive parallelism is the key to its speed. We are watching a fundamental shift in computing, moving from electrons to photons. This isn't just about one chip, it's about the future of tech and global power. If you want to stay ahead of these breakthroughs, make sure you're subscribed and have those notifications turned on. The story is moving faster than ever, and you won't want to miss what happens next. This isn't just a technical win, it's a potential geopolitical earthquake. For years, the US has used its dominance in semiconductors as a political tool to slow down China's AI progress. This photonic chip threatens to sidestep that entire strategy. Instead of playing catch-up in silicon, China is jumping to a new playing field where they might be in the lead. The part that signals they're trying to industrialize this is the production. ChipX launched a pilot production line capable of pushing out 12,000 6-inch thin film lithium niobate wafers per year, with each wafer holding around 350 chips. For this kind of advanced photonic chip, that's much higher volume than anyone expected. They've built a complete, closed-loop system. Chip design, fabrication, packaging, and testing all happen in-house. To put this in context, other global players are also racing ahead. In the Netherlands, Smart Photonics has been working with 4-inch indium phosphide wafers, while California's PsiQuantum is adapting 300 dB silicon photonics manufacturing. China's move to a functioning 6-inch TFLN pilot line is a sign that the competition has silently shifted. Of course, Nvidia isn't sitting still either. They are also investing heavily in optical and quantum technologies. But this chip could give China a path to technological independence for its next-gen AI and military tech without a single piece of sanctioned American hardware. Okay, before we declare the silicon era dead, let's inject a dose of reality. This is a huge achievement, but there are major challenges. First, that 1000x speedup claim needs independent verification. Right now, it comes from the developers. It's also critical to remember this speed is for specific tasks. This chip is an accelerator, not a universal GPU replacement. It won't be running your video games. Its speed is likely confined to a narrow set of AI problems. Second, manufacturing at scale is a massive hurdle. Working with exotic materials like thin film lithium niobate is notoriously tricky, and getting high consistent yields is a huge barrier. While they have a pilot line, scaling that to compete with giants like TSMC is a colossal task. Finally, the biggest mountain to climb might be the software. Nvidia's true dominance isn't just its hardware, it's the CUDA software platform. An entire ecosystem is built around it. This new photonic chip will need a powerful software stack built from scratch to let developers actually use it. Without that, even the world's fastest hardware is just an expensive paperweight. So, what's the big takeaway? We are at a genuine turning point. A team of researchers has said this marks the first time optical quantum computers can be considered industrial-grade products. It's a bold statement that the future of computing might not be written in silicon, but etched in light. While it's not an Nvidia killer today, it signals the dawn of a hybrid computing era. The data centers of the future will likely be a smart mix of both. Silicon will handle general jobs, while specialized photonic co-processors accelerate the toughest AI tasks. This could help solve the energy crisis facing AI and unlock new discoveries. The geopolitical shockwaves are impossible to ignore. This breakthrough shows that the next big thing can come from anywhere, challenging the old guard and proving that tech dominance is never guaranteed. We are seeing the first real shots fired in a new kind of hardware revolution. The age of photonic computing isn't a distant dream anymore, it's here. And it arrived a lot faster than anyone expected. Developments in AI and chip tech are moving at the speed of light. To make sure you get the latest analysis on how these breakthroughs will reshape our world, subscribe to the channel and join the conversation below. What do you think the biggest impact of this technology will be? Let us know. Thanks for watching.